My topic is the very important cleaning of pipeline systems, and my name is Hans-Gerd Hammann. I have now been self-employed for almost 25 years, come February, which is a significant milestone. And I would like to go into this evening with this detailed agenda. I would like to say a few things about us in a slide, about the company's development, then why cleaning is done, the 4 reasons that are important to us, and why we are called in. Then, of course, I will describe my complex procedure, highlighting its core features and benefits, and provide some information about the equipment needed for the respective operations in the drinking water sector. After that, I will mainly focus on the projects. And another point, which could be mentioned as a 6th one, is the highly regulated area. It involves pharmaceuticals, food, endoscopes, and medicine. I would also like to describe a little bit more about this in 1 or 2 slides. I want to start with some additional numbers and more data about the company Hammann. I have been on the road for about 24 years. By now we are around 70. Last year, we had a peak of approximately 75 employees in both field service and office roles. We have 2 locations, which are Halle Saale, Domnitz, and my central office in Landau-Anweiler. But actually, we are now in the process of establishing a 3rd and 4th location. One is in Salzwedel, where 2 of my colleagues are already based, and another in the west near Vechta, south of Bremen. So we are trying to expand a bit. We function with approximately 40 vehicles in various different sectors. Our primary area of operation is municipal water suppliers and wastewater disposal. So it's about wastewater pressure pipelines and everything related to water supply, from extraction to distribution. We work with pipelines there with diameters ranging from about DN 80 to 1200, and Berlin Waterworks is one of our clients, with whom we have also handled the really big projects. We have also been deployed on a clear water pipeline from the wastewater treatment plant with DN in the past before. The industry is also quite an extremely large and very important sector. The topic of drinking water installation is a small but very fine and very detailed area for us, because we have been extensively involved in many research projects in this field, which brought us into contact with renowned people like Professor Exner and Professor Fleming. Biofilms in domestic installations, that's where we were able to make a bit of a name for ourselves in the scene. That was also the basis for being recognized later in the industry. And what had been the Legionella in drinking water installations a few years earlier later also appeared in cooling plants and recirculation systems. Out of all this, Heyman Engineering also developed. This is about plant construction, and you will see 1 or 2 pictures of it later. Why should cleaning actually be done? We have several areas of operation. The first, of course, is the issue of contamination, which is on everyone's mind. Legionella is certainly a frequently encountered problem because it is being actively searched for and increasingly found. A lot is being done in this area. And if in the end, relatively little remains, then that is also a possibility for us to get involved, because these germs, these amoebas, and the Legionella and the amoebas often reside in the retreat areas. These are simply the deposits, the biofilm, but also corrosion products, or actually the entire conglomerate of deposits and films that form there. The next specimen looks beautifully old. Great picture, I think, which my colleague also found, but it is also one of the most challenging tasks. Pseudomonas aeruginosa in algae systems is manageable because it can be removed along with the soluble deposits. But in modern and contemporary new installations, they are indeed an extremely tough problem to crack. One often has to make use of all available tools, including chemicals and multiple cleanings and multiple chemicals. Our Mr. Birnbaum can certainly attest to that. A significant or insignificant reason for cleaning is often turbidity and clarity in water. We are increasingly and consistently dealing with turbidity issues, which in turn also lead to pressure and volume problems. This means that flow rates are significantly reduced, and not only are the aerators clogged, but a lot can also be removed from the pipes. And if, after certain periods of inactivity, you see such or even less turbidity when opening the tap, for example, in schools, then that is just the tip of the iceberg. When we get to that point, much larger amounts of turbidity will come out. And we can frequently contribute to improving these pressure-volume ratios through a variety of methods as well. And naturally, this also includes the thermal behavior in the circulation pipes in hot water systems, and as well, It must be said right away that the thermal balancing from stamp dish number 4 must indeed come into play here, because the entire balance will be significantly disrupted once we have cleaned such a system of deposits. And a fourth domain, which I wouldn't have thought many years ago, is indeed considerably about the installation or commissioning of new systems. This is becoming an increasingly significant area, because where systems are built, there are also production residues, whether it's shavings, seals, or sometimes other more or less randomly introduced materials like sand and so on. And such systems, if properly cleaned before commissioning, are extremely beneficial for their intended operation afterward and ensure optimal performance. So now to the detailed procedure, the core and key features, and the important benefits and advantages. I would like to start here with a very short and interesting mini film that we created for our endoscope topic. So here it will be shown that the deposits are removed from the inner surface with various dynamically designed, carefully calibrated, and meticulously fine-tuned impulses. Just a schematic visualization. How does Comprex Complex work now? It is essentially purely mechanical currently. We can certainly combine this with chemicals at some point in the near future, but our approach is to introduce and incorporate as much energy as we possibly can into the pipeline. And for that reason, we also push a strand through. So in the house, for example, it's a steep riser, and we also throttle it so that little water comes through. So from the left in this picture, little water is coming in. We relieve the pressure from the system and open 2 or 3 taps on the other side, depending on the nominal width, to release the pressure. And when we then inject air at a defined pressure and quantity, which is carefully measured and controlled, at an injection point, as we will see later in the demonstration, it will first displace the water in the system, pushing it out of the way. When the air energy is significantly gone due to expansion, it ultimately results in a substantial pressure reduction, ultimately resulting in a loss of pressure. The water blocks collapse, leading to partial filling. In this picture, you can see that maybe approximately 10 to 20% of the horizontal pipe is still filled. And when the next air block comes with 3, 4, or 5 bars air pressure against a 0.5 bars water pressure, then I can, through this extremely strong and very powerful expansion of the air, practically and almost create waves of water and generate them into blocks that also reach the peak with significant force and incredibly high energy. And then the expanding air, which is an extreme acceleration factor, significantly drives this water plug through the entire length of the pipe and forcefully. And we achieve speeds of approximately 10 to 15, up to 20 amperes here, and water is our primary cleaning agent. In this very high acceleration, it then rubs or significantly introduces the shear forces to the pipe walls. And it took us a long time, but the whole thing is also based on a physical effect, and that is the K-Helmholtz instability. So we don't just create any waves, but we carefully and meticulously lift them up, because the rapidly expanding air above the section of slow or stagnant water creates a powerful and noticeable suction effect. It's essentially the same effect as how an airplane flies, because the air essentially moves faster over the wing than it does essentially under the wing. So, and for this, we of course have a short film clip at our facility in Landau. At our technical center, we definitely have a test set up, DN80, 50 meters in length. In fact, we can generate up to approximately 3.7 meters of water flushing here, which is incredibly dynamic and operates in an extremely highly turbulent range. We can also add solids. This facility was funded by a research project, and Professor Fleming was also involved. It was about ensuring safe water. And here, where the monitor is very clearly visible, we very carefully place the magnets and precisely flush in small metal particles. And these small, tiny metal particles are firmly fixed by the powerful magnets attached very securely from the outside. And now I currently have a technical problem. Unfortunately, I might indeed need to try skipping ahead again. That is not intended. So I definitely believe this is indeed where we actually got stuck. We want to flush in metal particles, fix them from the outside, and then show through water flushing or later through our complex how much force we can actually apply to the pipe wall. Different magnets, different binding forces. Here comes the first water-air exchange, little dynamics. You will now also see water flying back on the right. A new plug is being formed, and with a completely different dynamic, the air block introduced at a distance of 24 meters will generate a water block that then flies through the pipe and scrapes off the deposits when you press your right thumb into the palm of your left hand. Everything you can easily remove with a pressed thumb, you can also expect to be effectively removed by Comprex. And we operate here with relatively low pressure, with approximately 0.2 bars water pressure and up to 3.8, 4.2 bars air pressure. So we don't apply high pressures, and the system is open at the back. And so we actually don't have any radial forces. The topic of pipe breaks is, of course, always up for discussion. We have more of these tangential forces always along the pipe axis, where the pipe migration also causes the deposits. That means we get speeds in the system of up to approximately 20 meters per second. This is the rapid flow that really takes off. In contrast to a water flush, where approximately 10 kilometers or about 3 m per s is indeed already quite a completely different scale. What is also important, which is very crucial, is water consumption. When you properly flush drinking water installations in a proper manner, you need to draw a significant amount of water from the water taps to ensure that the riser pipe, which usually measures 2 or 3 inches in diameter, is flowing in an optimal way. And these water quantities are indeed substantial. With Comprex, we can apply significantly more force to the pipe wall with much less water. And here is also a slide from Professor Kowalczyk, who calculated this using CFD simulation, as well as we apply forces that are 10 to 100 times higher on the pipe wall. That's on that topic. What is also important to me are these slides. When you imagine large buildings, most ordinary citizens typically don't even know how many meters of various pipelines and different types of systems are installed in such a building. And depending on the nominal diameter and other relevant factors, you can have an internal pipe surface area that can quickly and easily reach enormous square meter numbers. And if you take an example such as a DN, the fourth line, and you have a length of 200 meters, then you already have 33 square meters of area, which is the size of a large living room. And these areas need to be reached. When you think of chemical disinfection or chemical cleaning, it is introduced with laminar core flow, and then it has to slowly diffuse to the surfaces through a concentration gradient, and often there isn't much energy left. So this picture is meant to show that the surfaces are large and mechanical force is also necessary to remove something here. And I also like to demonstrate this particular slide in the industry, because in the industry, deposits increase roughness. That means it is indeed also a topic for energy losses. Rough pipes, where you have to significantly overcome the roughness, cost energy, and the biofilms deposits are present in all areas, whether in the drinking water installation sector or in the industry, in the cooling lubricant. Everywhere these are the retreat spaces for bacteria and contamination, such as we derive these advantages from it. We can come with our own additional complex impulses. We can get through fittings. Yes, we can also indeed practically introduce energy effectively into the upper seats of angle seat valves. We navigate around bends very carefully and extremely precisely. And when you perform a normal water flush at such a bend, in the vertically rising, practically flow calmed inner bend of the elbow, you really have almost no flow velocity and thus almost no detachment at all. Absolutely. The topic of nominal diameter variability is also important, as it often involves many changes in nominal diameters. From small to large is the normal flushing direction. Of course, you also have to consider the discharge. Variable lengths, we are not entirely unlimited, but we can practically work in large building complexes, whether they are clinics where the main pipeline in the basement can be several hundred meters long. These are all things we know from the municipal business. The second system is feasible, and a point is the one at the bottom in the middle. The impulse pressure always is below the system pressure, because the issue of damaging pipeline systems, even if it cannot be completely ruled out, must be prevented. Also important is a low fluid requirement. So here too, it is especially important for the industry in particular, where contaminated materials also need to be disposed of and also managed properly. My additional equipment and necessary tools. What specific equipment and tools will be used next? You can see here in the top right, this is our complex unit, which we use in the municipal sector. We have a compressor in there generating air at approximately 10 bars pressure at about 3.3 cubic meters. The whole process involves 4 stages of filtration, hygienically flawless, and up to the carbon filter, activated carbon filter as well. And then you need additional equipment for the drinking water installation. That includes another vehicle. And as you can see in the bottom right picture, you also need small materials. We need all kinds of fittings. We also need aerators, seals, and aerators that are completely dirty, which we see as minor repairs that should be replaced immediately. That's why we simply need such parts. So what we also have here in the picture is indeed the topic of disinfection. We also offer system disinfection, of course, always in coordination with clients. Subjecting a nursing home to a thorough, comprehensive, and meticulous disinfection process overnight is no small undertaking. This needs to be properly planned, and the residents need to be informed about it. But if we do it, we want to perform a proper disinfection, which can also be understood as a safety measure after the cleaning. We have a relatively new development here, which is our mobile disinfection module. Here we have a very important static mixer that actually produces extremely and highly correct and accurate mixing ratios. Unlike a normal dosing pump, which only achieves an approximate mixing ratio, this is our mobile complex unit for drinking water installation. You have to imagine from our large trailer, we control the pulse output for the large pipes for operations in the municipal sector and also for larger pipes in drinking water installation. And now we have a mobile unit here that allows us to position the thing directly in the basement, which is very convenient and efficient. From the back, we get water and air here in the middle picture. You can see the entrance. We get water and air and can then directly generate our complex in this facility. The whole process is controlled via touchscreen. And you can see in the lower middle picture that the thing is also divisible via this one black connecting piece. That means 2 men can essentially carry the lower part to the basement and then bring the control unit to the upper part. So how does it proceed inside the building? We have here, now we show with this small magnifying glass, outside is our air generation, and we transport the complex control, the mobile one, down to the basement. And then we go with compressed air through the complex control unit into the cold water and the hot water distribution. For this, some modifications usually need to be made, including in the circulation, just to show that. For the braid points, you go naturally from large to small. First and foremost, the primary sewer lines are cleaned, and then we move into the individual wet cells or residential living units or areas to properly clean the more sensitive extraction points, all the way up to the single lever mixer. And here too, dismantling is often necessary. If these are some special showers, then it can sometimes be quite elaborate. That's how it looks. Up here in this area, we practically go selectively. We go riser by riser carefully. We also try not to completely shut off water to buildings, but rather to individual risers day by day in order to ensure that residents are only subjected to a limited window of inconvenience or water unavailability. We do this as much as possible. Here below, you can see a few small and compact handheld cyclone separators. In the middle picture, you can see on the top left where the hose is docked, and in the center where the connections need to be prepared accordingly and appropriately. That's what we naturally like to see. When something like this happens, every customer is extremely satisfied. But the discharge volumes are often quite substantial, especially with galvanized pipes. You have to be careful that the drains don't get clogged in some cases. We've had that too. Yes, you can see here, the aerators are maybe, the blue one already has. You can see a few particles on the left side of the picture, but otherwise relatively clean, and still so much sludge comes out. That's how we go through showering. Yes, the picture on the right is the more interesting one. Here you see a cyclone separator that sits on the toilet, where various connections up to 4 can be attached. It concerns the circulation movement. In the lower part, there is a pipe that goes up another 10 centimeters into the container, slightly. The water gets backed up, the container becomes heavier, and most importantly, the rest goes down the drain. And the car air filter is extremely important to ensure that aerosols do not bother our team, residents, or passers-by, because aerosols have previously caused one of our employees to come down with Pontiac fever. It is very crucial for maintaining a safe environment. Caution is indeed the mother of the patient box. We also often regularly see such discharges frequently in the movement images of rehabilitation units. That is quite extremely unpleasant. What we really don't like to do is indeed definitely go through such a shower hose, as you can see in the picture on the right. We often believe that these items should perhaps also be considered as spare parts, because if these are not drinking water safe hoses and there are deposits in the plastics materials used for them, then a back contamination issue could quickly occur. So in that case, our hands were tied at some point. Now to some interesting projects. I have brought you, I believe, 3 or 4 examples. Here, Legionella in an indoor swimming pool, beautiful facilities, some of which include purchased images, as we are naturally also committed to discretion. But here the task was to eliminate the contamination with Legionella pneumophila. The thorough and comprehensive cleaning of the drinking water installation was scheduled, and after the cleaning, the entire system was to be entirely and completely disinfected with chlorine dioxide. And as always, not everything was normal. We had to do it at night and on weekends because the operator, of course, wanted to keep the pool open during the day. So that was all certainly before the corona times. Today, it would be a bit easier. The task involved 95 cold water taps distributed across 56 showers, 37 wash basins, 23 toilets, 4 sinks, outlet valves, bathtubs, rinsing basins, drinking basins, and essentially the entire range of tap points needed to be covered. Yes, and I was told indeed, a swimming pool in the large and bustling city in Hesse, and there were relatively new pipes made of stainless steel before. Here in the bottom right picture, you can clearly see how the pressure reducer is also docked with our complex and intricate unit in this image. And the task is actually always the same: mechanical and thoroughly careful cleaning and the use of air water, providing the treated air access through adapter connections, and then cleaning line by line up to the tapping points in a systematic manner. The implementation of the measure was then organized over 2 consecutive weekends. Biofilms, removing contaminants as a breeding ground for microorganisms, that was the job. And yes, indeed, there were no more detectable Legionella and other microorganisms afterward. Of course, some time has to pass here as well. We no longer take samples. We used to do that in the past. And we say we do the manual work in a detailed and thorough manner, and then neutral parties should simply inspect us and comprehensively ensure that absolutely everything is in order. Include the operation as well. 3 technicians, 44 hours on site, which then corresponds to the time expenditure causing the costs. Here, corrosion problems in the senior home. Again, there was an entry of deposits and corrosion products into the system, including corrosion of the galvanized steel pipe within the system itself. It was also diagnosed that these issues came from outside, from the previous supplier, and we had to clean the hot water and circulation water pipes, all while keeping the system running and taking into account the water usage times of the residents in an efficient manner. Not quite easy, but manageable. Working hours between 7:30 a.m. and 5 p.m. And if you start with open, honest, and consistent communication with the staff and residents for the first 1 or 2 days, supported by the management or organizers, you will receive excellent and consistent support from the people living there. And yes, indeed, there were approximately 280 hot water taps that we had to work on. There were 75 rooms in the main and auxiliary buildings, additional areas like the kitchen, station bathroom, and visitor restrooms. And here we practically used the Comprex system in a 2-step process. First, the cleaning of the main hot water and circulation pipes, and then the sectional cleaning of the distribution networks and taps. So first the parts that affect everyone, and then some. Everyone will have to grit their teeth for a while, to put it that way, because there will be no water available for a certain period, and then it can be done in stages. The bottom right picture needs explanation. It was taken from above into such a cyclone separator. You see these 4 additional side branching pipes which create the circulation and rotational movement and flow. And you can see below in the middle above the drain, the ERKG pipe, and above it this dark brown fill level. And in the next picture, you can clearly see the small or medium-sized parts that were very carefully removed. There was a relatively high discharge of black-brown turbidity. We were able to mobilize a lot. and even 2.5 months after cleaning, no turbidity was detectable. Now, to be fair, it must be said that this is often a collective result, because when we change and clean galvanized systems, subsequent turbidity can logically occur since the surfaces remain corrosive. And in this case, the addition of inhibitors is often, typically necessary. In many cases, the inhibitor dosages are already present, and only after the cleaning does the issue of turbidity due to fixation on the walls also disappear. Here, 3 technicians, 70 hours on site. The job scope, an interesting task, dates back a few years and involved in a children's clinic in the Bavarian region. Here we had contamination problems, including both Pseudomonas aeruginosa and Legionella. Officially, I could even mention the name, but I don't think it's really necessary. It was cold, hot, and circulation water, so a complete system. And here too, we have to say, it is becoming more common that when you are already on site, you not only handle the hot water, but also take care of the cold water as well. It might be about 25% more effort, but we are also increasingly noticing Legionella issues in cold water, which will probably align with your experiences as well. Turbidity problems were an additional issue, and we had to carry out the process over the weekend since the operating room of the children's clinic could only be shut down on weekends. We were dealing with 71 cold water taps and 59 hot water taps. The hospital had 3 floors, and in the picture at the top right, you can see an interesting detail, a subsequently installed tapping saddle. That's another point. We always have to get into the system, and if something like that isn't available, then a called-in installer must also be able to create such access for us. Then back to the normal sequence concerning the air adjustment complexity, and again, the distribution through the taps. And the turbidity was, of course, an important indicator here. However, this means that when they work in new systems, often also in stainless steel, and they are dealing with Pseudomonas or whatever, and they don't have turbidity as a performance measure or indicator, then it really only comes down to the pulse count. Then the number of impulses must also be the criterion here, because only crystal clear water is being carried out. We were able to successfully mobilize deposits and biofilms. This is a beautiful image because it shows the discharge, and on the right you can clearly see an extended index finger which shows all of those sandy residues present there. Up to that point in time, a lot of turbidity had also gone down into drain pipes as well. 3 technicians worked for about 22 weekend hours on site. So the last example, number 4, for instance, corrosion products in a residential building, such as here too, a larger scale, 700 cold water points. And I believe maybe Kai Birnbaum can, in my opinion, provide clarification on this later. As I recall, it was a relatively new building where a construction mistake or error occurred. It was an insurance claim, and embarrassingly, a large number of the risers were installed using black steel, if I am not mistaken. Unfortunately, attention was not paid here. Corrosion was thus spread extensively throughout the entire system, and the system had to be completely cleaned again. A really large facility with 220 residential units was a logistical feat to coordinate everything. And again, the first step was the basement distribution in a night and fog operation, or 2 night and fog operations, and then riser by riser, including all the apartments, again with notifications and residents. Most of the apartments were already rented and sold, so it wasn't easy, but we managed to handle everything. We initially trapped the items with cotton to manage the situation. At the outlet, we also hung pillows to catch any flushouts. This meticulous approach enabled us to document everything properly and address each issue in the insurance matter with all the necessary details and evidence, ensuring a thorough and accurate claim process. We were here with 3 technicians for a very long period, indeed almost 2 months on the job, actually. So that was actually my main presentation in just over 35 minutes, actually. And now I would like to move on to a few slides in our area of pharmaceutical color, medicine, the special hygiene challenges, and highly regulated areas, and maybe also show a little bit more details about our range of various different devices and equipment items, Earlier, you saw this mobile complex unit for drinking water installation. We also build other such machines. This is indeed about this small link, the MCU, which is specifically designed for the injection molding tools, such as for plastic injection molders, for instance, medical devices like syringes, which can also represent other needles or anything else, such as the middle system, which is an ER, is sufficiently sized for the machines that spray various types of fluids and coatings, but it can also be used in the cooling systems of other metalworking machines, ensuring optimal performance and efficiency. And on the right, our large main unit. This is what it looks like in our small workshop when two such units are put together. You can see the touch screen. It is definitely very important indeed that the know-how of our engineers and technicians has now been integrated into software, so that we have application recipes which are capable of correctly addressing similar tasks repeatedly.